So thank you very much. My name is Jennifer Lee. I'm currently a lecturer at Northumbria University in Amsterdam, and I am the chair, as you saw earlier today, I'm the chair of the Human Data Interaction Committee for EC3. So part of our role within the EC3 is to publish papers and research and kind of show the things that we're working on, and this is one of the things that we've been working on for the last, year. The paper, so I'll introduce the team who wrote the paper, the project, and then kind of the drivers behind it, the findings, and then the plan for moving forward. So we had 8 people working on this project, which, as you can imagine, is great to have all of that knowledge, and also can be a challenge in terms of not at least coordinating meetings, but also having everybody on the same page in terms of evaluations and things like that. So it was a really nice project to work on, and the result is the paper that you will see. So the project is focused on aiming to create a theory or establish an underlying theory for human data interaction in construction. And the reason for this is, we've been a committee for, say, around 5 years now, and it's still relatively an emerging concept. Has kind of moved from human-computer interaction towards human data interaction. And we have been working on a number of projects, and we're at the point where we really feel that we need some kind of unified theory of human data interaction for the built environment that would allow us as a springboard to kind of move forward for other projects. And so this kind of baseline theory is really something that we're working towards to allow not just us as a committee, but other people within the automation and construction community to move forward in this field. So for this particular study, we did an inductive literature review, focused on the themes related to the built-in environment that we are focusing on with, as a committee. So they're not an exhaustive list of themes. They're the themes that we focused on within the white paper, which I will present later on this afternoon. But you can see here, we looked at blockchain, machine learning and deep learning, robotics and for industrialized construction, censored construction sites, smart buildings, and virtual reality and augmented reality. So in terms of conducting the review, we each took on one of those roles. We searched for papers within the field of human data interaction, within the built environment where possible, because it's still an emerging field. There really wasn't a huge amount of papers available. And we used this criteria that is within the kind of remit of the committee to use to evaluate the papers. So we had understanding and evaluation from an end user perspective that looks at users and behaviors around data, individual societal implications of emerging interactions, uses of ICT and AI-related applications, and then from a technology perspective, looking at existing or emerging platforms, architectures, component technologies, interactions between human actors and data systems, testing methods for existing technologies and design methodologies. And then finally, foundation, which is where we can start to see emerging theories, methodologies associated with human data interaction that we could bring together and kind of synthesize for what we want as a community going forward. So in terms of, I'm going to go through these next few slides pretty quickly because you can find this information more detailed in the paper. But the key findings from each of the categories are that from a blockchain perspective, we have a shift. Blockchain has come about because we need a shift from kind of current thinking around exploitation of data and capitalist systems towards more democratic and open processes and systems that limit the ability of exploitation of data, but also gives us the power to do more with data in terms of an interaction between humans and kind of technology. And one of the key things from the papers that we looked at for this literature review was around increasing agency of the individual around their data. From the machine learning and deep learning perspective, there was kind of a focus around human in the loop. So using the different subfields of AI to study data to make decisions, how do we integrate the human into that environment, and integration with things like IoT, machine learning, deep learning, to adapt systems to build to users' needs. But we need to consider things like physical information security, establishing responsibility, rights over data, and so on. Robotics was focusing around things like physiological impacts around, say, anxiety, stress, cognitive load, negative emotional state in terms of interacting with robots and working with kind of that robot within that environment. So the focus is really on human-robot collaboration, so how can humans and robots collaborate together? But that kind of asks the question of how much agency do we give to robots, how much agency should humans have in that relationship? From a sense of construction perspective, human data interaction related studies exist across several areas around safety, worker ergonomics, productivity, measurement monitoring, activity monitoring, recognition. What was interesting for this category was there seems to be quite a lack of a basis around human data interaction for this, considering there was so much integration between humans and data. There's really not a lot that we kind of could take from a theoretical perspective to put into the theory, so we need to really focus on that going forward. Smart buildings, data really needed to effectively and efficiently respond to occupant needs, and what that means is the users need to be willing, active participants in that system, in that ecosystem, to engage with data to enable this. And so while we can do a lot to respond, to have buildings respond to needs of users, we really need to have that integration. That's really key. And from a VR and AR perspective, human cognition, understanding human cognition is central when we want to exploit virtual reality, for example, for visual analytics. Data flow between systems used in the construction lifecycle for VR and AR is definitely still an issue that needs to be addressed going forward. So once we each reviewed our kind of respective categories, this is kind of half the table that you can see, and you're not intended to be able to read this, but it's just an indication of kind of how we did the evaluation. So we put it all into this table, so you can see each of the categories across the criteria that we looked at, and it was my job to synthesize what that all meant, to try and identify different kind of similarities and elements that we could start to think about that would really emerge, that we could put into or use as a basis for creating a theory of HDI for the built environment. So the key things that came out of the evaluation were a number of different kind of what we call potential elements that could form this theory. So trust was really one of the key elements around all of these different technologies in terms of being a central facet of a system when considering the interaction between humans and data. So we as humans need to be able to trust the system or what's happening with that data is in our best interest or for the good of the objectives of the project or what have you. So this is applicable in terms of human-centered systems, as well as humans knowing the correct data are being used when data-driven decisions are made about or for them, without human input, especially when we relate to kind of well-being. Game theory has come up quite a lot in terms of being a considered way to encourage engagement with data, so how we actually get humans interested in engaging with that data, which then relates to empowerment of humans. So when collaborating with technologies, for example, robots or surveillance systems, moving towards automation that partially removes human control. So humans are often wary of new technologies that can result in an unwillingness to collaborate. So with the concept of HDI, we need that interaction, we need that collaboration. This links us to potential issues of safety of the human with physical and psychosocial perspectives, particularly when working with hardware, kind of robotics or wearables and so on, and software concerns that may be less kind of detachable. Accessibility considers how humans interact with data and affects how they make sense of correlation and causation of those data. Move into understanding, so enhancing understanding through data visualization, for example, to increase accessibility, and then again, willingness to engage with the data. And then finally we have what was the initial kind of theory around human data interaction, but not specific to the built environment. These three pillars of agency, legibility, and negotiability, which is kind of a baseline that we want to build on top of to make the theory for the built environment really more specific. So agency is really associated with the ability of us as individuals to be able to opt in or out of data systems, as well as having control to amend our own data or comply with GDPR, for example. Legibility is the ability to understand data and their processing, as well as ensure transparency. And negotiability, so relationships between data and the processing, including the regulatory environment, societal norms, and individuals' changing attitudes regarding personal data. So these are the key things that have come out of the review that we're going to take forward and explore more with an extended review over the next kind of few months. The idea is that what we kind of get from a much broader, deeper review is the emergence of a theory specific to the built environment that we would aim to publish as kind of and target as a middle range theory that we can then test and refine as we kind of go through and as more people get into the field and so on. So the project has been led probably by myself and May, but May Shayboun, who's not here unfortunately. So we are going to continue with this over the next few months, but that's kind of where we're at. And I think that's probably gives you a kind of good idea of the kind of things that we do within the committee as well. We do more technical projects as well, which I'll talk about this afternoon, but that's where we're at. So thank you very much. Any questions?